Okay, just turn my screen. Okay, this doesn't lag too much. So last week we ended off with angles, and so I'm just gonna quickly go back over them because I know I sped through them a little last week. So the first angle we learned about last week was the acute angle, which we have right here. And like I said last week, an acute angle is just an angle where if we have an angle x, that is when x is between 0 and 90 degrees. And really it's just x less than 90, but an angle cannot be 0 degrees. So we have x is between 0 and 90 for an acute angle. A right angle, like I said before, is just x is equal to 90 degrees, and we always denote that with this little square right here, so we always know it's a right angle. Obtuse angle, like I said before, is any angle greater than 90 degrees. And technically, I'm pretty sure it's also when it's less than 180. And then a straight angle, which I didn't say last week, is just going to be a line which is equal to 180 degrees. So a line will always be 180 degrees, no matter which way you look at it. So this will be 180. And this is an adjacent angle, which I didn't talk about last week, but this might look like it's just a right angle with a line going through it, but that's not all it is. It's actually two angles. We have an angle right there and an angle right here. So we'll call this angle X and we'll call this angle Y. So adjacent angle is just when there's two angles like X and Y here that add up to 90 degrees. So that's just what an adjacent angle is, if you ever need to know that more. And so I think that's most of the stuff you have to know about angles. I will go over how angles work in parallel lines. So I assume all of you know what parallel lines are. If you want, you can just drop it in chat what the definition is. So parallel lines are just two pairs of lines that never meet, and they will be denoted like this. Yeah, two lines that never intersect or touch. Yep. And so there'll be lots of questions on the test that will have like angles like X. Uh, yeah, just do X, Y, A, B, X, Y, A, B. Right? And there we go. So if we have an angle like this, let's call X, we'll call this 60 degrees. And we'll call B 120. So I want you to tell me what we'll call this right here. Call this W. So find A, Y, and W. If you know how to do it, go ahead, drop it in chat if you can just tell me the answer. Okay, I see A is 60. I see W is 120. And I see Y is 60. Good job. So these are all correct, and I'll explain why. So when you have two parallel lines and a line that intersects them like this, these two angles that oppose each other will always be equal. So I'll write opposing angles are equal. And this applies to mostly parallel lines. So in this case, we'll have 60 is equal to A because they are opposing. And we have Y. So then another thing about Y is that with these two angles right here, this angle and this angle are going to be also, they're going to be the same too. And I forget what the technical term is called, if anyone in the teachers remembers, but just know that when there's two angles, so
Like
there's two angles,
angle?
like what?
Interior angles?
And yeah, you said interior, interior.
Yeah, yeah.
Yeah, so the interior angles will always be equal. So then this one and this one are this one and this one are always equal, but this one and this one are not equal. And then like here, we know that W is opposing 120, so W is also gonna be 120. And an easy way to check your work is that you know that since these are both straight lines, this entire thing right here is gonna be 180 degrees. Same down here, 180 degrees.
Just a quick correction on what I said. So when the two angles opposing each other through the lines are equal, those are called vertical angles.
Okay, yeah,
Interior angles are uh supplementary. So like the two angles inside of the parallel lines are the interior angles, or interior angles are like inside of the shape.
yeah,
Yeah. But if the two angles that oppose each other are equal, that's called vertical angles.
yeah. And so just a quick recap of that. We know that we know that I'll put the ones that equal each other in the same color. We know that this one right here and this one right here are equal. And we know that this one right here and this one right here equal. And this one's equal to that and like that. Like right that. Like that. So the vertical angles are always equal, and the two opposing ones that are across from each other are also equal. So just remember that. And an easiest way to check your work is to make sure that all of these angles add up to 360 because this is like kind of like a circle. If you look at all the angles, and a circle is always equal to 360. So I'll just write that down. Add up to 360. All right. And just a little bit more work with angles. We're going to go to sum of the angles in a polygon. So can anyone tell me how many degrees are in a triangle? All right, I see 180. Good. What about in a square? Okay, see 360 because of the four right angles. And what about a pentagon? I see 520. It's actually, oh, I saw a 540 in there. It's actually going to be 540. Going to be 540. And can anyone tell me why that is? Okay, I see because it has five sides, and I saw someone drop the formula in there. So that's actually correct because the degrees of a polygon is directly correlated to the number of sides it has. And we can actually make a formula out of this that I think you should remember. I see Vishwas drop it in chat. It's going to be n minus 2 times 180, where n is equal to the number of sides. So the total degrees in any polygon is just going to be the number of sides it has minus 2 times 180. So with that knowledge, could you tell me what the degrees are inside a nonagon, which has 9 sides. How many degrees are in a nonagon? Okay, I see 1260. Okay, I'm seeing a lot of 1260s in the chat. Let's just see if that's correct. So applying this formula that we have right here, we'll do 9 minus 2 times 180. It's just equal to 7 times 180, which is going to be equal to 1260 degrees. That's correct. Good. And the only shape that you can't use this formula on is going to be a circle, because a circle technically has no sides. I think it's technically an infinite number of sides, because a circle is going to be 360 degrees. So it doesn't necessarily adhere to this rule. Yes, and there's no like actual angles out here because, like I said, it's an infinite number of sides or no sides, and so it's going to have 360 degrees inside of it. And then, is that all I had? Sure. So I think I'll throw up one more problem up there. So let's just, all right, exterior angles. Exterior. So exterior angles, it's going to be something like this. Or I believe it is going to be, is it X right there? B. X is equal to A plus B. That's what an interior, I believe, is an exterior angle. I don't believe you have to know exterior angles for this test. I think it's mostly going to be the interior angle stuff that we talked about up here and just the total number of angles inside a polygon. But if you were to get a triangle that looks like this, where you have an angle out here and you're asked to find x and you're given b and a, it's going to be x is just equal to the sum of b and a. Because right here, let's call this c. A plus b plus c is going to be equal to 180. C is equal to 180 minus a minus b. And x is equal to 180 minus c. So you just throw that down here and you get 180 minus 180 minus a minus b is equal to a plus b. So then x is equal to a plus b. I think I learned this in UMTYMP, so I don't think you have to worry too much about exterior angles. Just make sure you recognize this formula if asked and know, I would say memorize, just know these ones too. These ones you should have memorized already. This one, this one you can use the formula for. And also make sure you don't forget that a circle has 360 degrees in it. All right. I'm going to do one last I'm going to do some 3D. Let's do some volume real quick. Gonna be a little off. All right. This is gonna be a rectangular prism with sides A, B, C. Find the volume and surface area. Okay, I see a lot of A, B, C for the volume. That's correct, because for a rectangular prism, it's going to be it's going to be length times width times height or depth. Yep, it's the same concept it is for area. It's going to be length times width, but you just multiply height too. It's going to be multiply all three numbers you're given. And I don't think I see any answers for surface area. So surface area is just, okay, I see an answer to put in the chat for surface area. So surface area is just going to be the sum of the area of all the faces. So in this case, we're going to have, I'll just redraw them down here. They're not to scale. This will be AC. This will be AB. And this will be BC. So we have three unique faces on here that are both going to be, there's two of each of them because they oppose each side. So the area of this one will be AC, this one will be AB, and this one will be BC. And yes, like Arav said, all of them times two because there are two pairs of each face. We get surface area is equal to 2AC plus 2BC plus 2AB. And these will both be your general formula for a rectangular prism. Sorry, I just forgot to see down here. So you could either memorize this or just know that you have to just add up the area of all the faces. So those are the biggest ones you have to know. It's going to be the same for this formula will be the same for like triangular prisms, only you have to change length times width to half length times width. But I don't think that's going to be the biggest issue. And then I think I'll do one last thing. We're going to do scaling shapes. So let's just say, oh, what about sphere? Okay, I'll just draw a sphere. I don't really know how to draw a sphere or something like that. The volume of a sphere is going to be 4/3 pi r cubed. Correct me if I'm wrong. So this is just a formula you have to memorize, and it's going to be r is the same thing as it is for a circle. It's going to be a distance. Oh, I say area. This is the volume of a sphere. There's no volume. There's no area of a sphere.
The
And then,
surface area for a sphere, though, is 4 pi r squared.
okay, 4 pi r squared surface area. Yeah, they don't, I don't think they'll ask this, but just make sure you memorize these. And as you can see here, it's going to be r squared for area and r cubed for volume. Like you have the second dimensional space and the third dimensional space. And the last thing I'm going to do is just going to be general scaling of shapes. So if I'm given two triangles, not drawn to scale, let's say that this is going to be X and this will be Y. All right. And let's say area equals, I'll change this from X and Y. This will be X and Y. Let's do this will be 4. This will be 5. No, this will be 2. Okay, area, this will be equal to 16. Find. No, wait, that's wrong. Shoot. What I do for a practice problem. I'll just do this. 2, 3, x9. Find x if the area of the second rectangle is I see a lot of you put in 6. That will be correct, I think. Yeah, because this is going to be scaled by 3. I was trying to think of if they would ask a question with the areas included, but I don't think they usually do. But yeah, just know that if they give you two shapes and they call them, I think it's similar. They call similar shapes is just when they're like the same, they have like the same ratios of each thing. So in this case, you have to know that,
The same scale factor?
yeah, same scale factor or like same ratio of the sides. So in this case, we'd have to know that 3 over 2 is equal to 9 over x. And with some simple simplification, we get 3x is equal to 18, x is equal to 6. That's all I have for scaling shapes. It's not too much, just know the scale factor and ratios of the sides are equal. All right, that's all I have for the geometry. I think we move on to data analysis now.
Yep. Let me go ahead and share my screen. All right, great. All right. So one of the questions on the UMTYMP test that they'll ask you to do is analyzing a list of numbers or giving you like some data sets that they want you to ask to do some simple things on. So for example, they might give you this list of numbers. So let me just write some random numbers in here. Okay. I'll put some commas here to make it more clear. So they might give you this list of numbers, and then quantity A might be the mean, and then quantity B might be the median. So this is what a question could look like. So we're going to go over how to do all of this right now. So let's start off with the mean. So the mean, which we usually denote with like a bar on top, this is just going to be the sum of each of these numbers divided by the total amount of numbers. So when someone says average, the word average, like on average I do this, or the average height in this school is like this tall. When people talk about average, they usually talk about mean. So there are many types of means. So I'll talk about the different ways to measure averages in a moment, but mean is the most commonly used, or it's like considered to be the default term. There are many types of means, but usually, or really, they'll only ask you about one mean because the other types of mean are complicated. So the mean that we're going to work with is called the arithmetic mean. And the reason why it's called that is because to calculate this mean, we're going to add all the numbers together and divide by the total amount, like I said earlier. So to write that out, I'll just say add all the numbers and then divide by total number of numbers. So let's just say total amount. Okay, so to do this example, let's just do the example calculation. So to calculate the arithmetic mean of this list up here, we'll just do 1 plus 3 plus 4 plus 7 plus 6 plus 13 plus 12 and divide by 1, 2, 3, 4, 5, 6, 7 numbers. And to calculate this out, we'll just have to go through it. So this is 4. Okay, we'll have 8 now, 15, 21, 34, and 46. Okay, so we'll have 46 over 7. So this is the answer. This can't be simplified anymore, but this is the arithmetic mean. So when I talk about there's different types of means, I can just list them out for you briefly. So we went over the arithmetic mean, but there's also something called the geometric mean and the harmonic mean. But we don't need to know these because these are um, beyond the scope of the test by far. And many people actually don't even know that these means exist. So when the test says average or mean, you can just assume it will be the arithmetic mean. All right, so let me give you guys a quick practice problem. So I want you to go ahead and calculate the mean of this data set. Oh, this should not be, this should be like this. So go ahead and calculate the mean of this data set right here and put your answer in the chat when you're done. Okay, I'm seeing a lot of great answers in the chat right now. So the correct answer is the mean is 50.5. So the process is exactly the same. We just have to find the total sum and divide by the amount of numbers we have. So if you recall, to find this total sum, we're going to use our n times n plus 1 over 2 trick. So plugging that in, we'll have 100, which is our n here, times 101 divided by 2. This is the sum, right? So let's just evaluate this. This is 50/50. So how I did that quickly is 100 divided by 2 is 50, and then we'll just have 50 times 101. And this equals 50 times 100 plus 50 times 1 if you do the distributive property. And this is very easily just 5,000 plus 50, which is 50/50. Okay. So now that we know it's 50/50, we just have to divide 50/50 by 100, and we get 50.5. And to point out what Arav just put in chat, it is true that you can just do this in one big calculation. So you don't have to go through each, the numerator and the denominator by themselves. You can just plug everything in at once, and then it will simplify very easily. So um, great comment there. All right. So now let's move on to the median. So the median is the middlemost number in a list. So what does this mean? That means if I have my list of numbers here, I'm going to pick the middle number. So first I have to sort them from lowest to highest. So I have to order them up. So let's start with 1, 3, 4, 6, 7, 12, 13. Okay, so this is the list in order. And now all we have to do to find the median is find the middlemost number. So let's cross out 1, cross out 13, cross out 3, cross out 12, cross out 4, cross out 6. Or 7, cross out 7, not 6. And we see that the median is 6. So that is the way to always find the middlemost number. You will order the data set and then cross out the numbers. All right. But you may notice that this only works if we have an odd amount of numbers. So what happens if we have an even amount of numbers? So let's say I have the exact same data set. So I'll just write them in order again. But we have one extra number. So now we have 8 total numbers, which is an even amount. So let's just go through and see what happens. So cross out 1, cross out 50, cross out 13 and 3, cross out 4 and 12. And oh no, we can't cross out these two numbers because then we have nothing left. So if we happen to have two numbers remaining, the median will simply be the mean of the remaining two numbers. So the median will be 6 plus 7 divided by 2, which is 6.5. All right. And finally, we'll have one more of these averages or these things that measure average. So far, the mean and the median, these things are what we call measures of central tendency. So they measure like how they're like a number that summarizes the middle of a data, right? So you can imagine the median is literally the middlemost number. The mean is kind of like the average number, which happens to also be a middle number. And the last type of measure of central tendency is called the mode, okay? And the mode is simply the number that appears most in the data. So the number that appears the most in the data. So if we look at this data list, this doesn't have a mode because each number only appears once. But if I give you an example, let's say I have this data set right here. So it'll be 1, 1, 1, 2, 2. It's not a 33, even though it's spaced kind of badly. Let me fix that. So if we have a pretty long list like this, the mode will be 1 because 1 appears most on this list, right? It appears 6 times in these spots. If there isn't a mode, is the mode 0? No. If there isn't a mode, the answer is there's no mode. Because we cannot say that mode is 0 because 0 could be a number in the data list, right? But that's a great question. Okay, so let me just give you a quick practice question for the mode, so you can put your answer in the chat. We'll do a practice question for mode and median here. So I'm gonna give you guys a list, and you can tell me the mode and the median. You can also feel free to calculate the mean too if you want. So let's go ahead and create a data set. Okay, so go ahead and find the mode and the median, and might as well throw in the mean too. So find the mean, median, and mode of this data set. You can put your answer in the chat when you find it. So this data set is a little tricky because I include a little trick here. There's both 1 and 2 appear 3 times. So this is actually something we call bimodal. So bi means 2. So bimodal just means there's 2 modes. So the mode will be 1 and 2. All right. So if those of you who are still stuck on finding the median, I ordered the list for you here. Okay. Let's go over how to do this. So as I said earlier, this list is bimodal, so there's 2 modes. The mode is both 1 and 2. Now to find the median, you can go ahead and order the list, or if you think ordering the list is too much work, you can just you don't have to reorder it. All you have to do is cross out the lowest number, cross out the largest number, cross out the next lowest, cross out the next largest, and keep on going until we have 2 numbers left. So that means the median will be 3.5, right? So it'll be the average of 5 and 2. And we can just double check our work here. So let's go ahead and do this. Wait a second. What happened here? Oh, okay, I know what happened. Okay, there we go. I accidentally crossed out too many. Okay, so we're right. So we're left with 2 numbers. So obviously the median will just be the average of the two, which is 3.5. Okay, perfect. Now we only have one more measurement to go over, and this is something called the range. So the range is a measure of spread, or how spread out the data is. So what the range is, it's the largest number minus the smallest number. So this is pretty simple. So if we want to find the range of our data set back here, I know there's a lot of writing on here, but the range would be 14 minus 1. So 14 is the largest number, 1 is the smallest number, so the range is 13. There is another measure of spread called the standard deviation, but that's too complicated, and that will not be on the test. But this is the more commonly used measure of spread. It's called standard deviation. I'm sure you've heard of it before, but range is what will be on the test. Okay. let's go over something called percentiles now. So if we recall our median, the median is the middlemost number, right? So that means that 50% of numbers are below it and 50% of numbers are above it. So this is what we call the 50th percentile. So a percentile basically just means how many more points, how many more numbers is this number bigger than? So, um, for example, if I had a list of numbers from 1 to 100, 100 would be the 99 percentile because it's bigger than 99 numbers, right? 1 to 99. So that's actually a tricky thing. It's not the 100th percentile. There's no such thing as the 100th percentile. So 99th percentile or 99.9999 and so on is the largest percentile. Okay, so the relevant percentiles to know is the 25th percentile, the 50th percentile, which is the median, and the 75th percentile. So the 25th percentile is the number between the first number and the middle and the median, okay? And the 75th percentile is a number between the median and the biggest number. So let's see if we can calculate this quickly. So let's actually just use our exact same, well, actually, let's use a different one here. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's calculate the 25th, 50th, and 75th percentile and put it in the chat. So just to reiterate, the 50th percentile, remember, this is the median. The 75th percentile is the number between the median and the largest number. And the 25th percentile is a number between the smallest and the median. Okay, let's go over what the answers are. So I see some answers in the chat. So let's find the 50th percentile first because that's the easiest. It's just the median. So instead of crossing them out, I'll just underline them because I don't want to like make them hard to read. So we're just gonna, this is already in order. Okay, so that means 14 is the median or the 50th percentile. So this is the 50th percentile. Now to find the 25th percentile, we're gonna find the number between the smallest number and the median. So let's do that. And we see that 1 is the 25th percentile. And then on this side for the 75th percentile, we see it's 19. All right. Now let's get into some quick probability here, and then we'll go and do our fun little game that we have prepared for you guys.
We have to do the game.
What do you say?
You have to do the game.
Yeah, it's a fun review game. It's going to be math related, of course. Okay, so for probability, I'm sure you guys have heard of this. This is like how likely is something to happen. So for example, if I say, what's the probability of getting ahead when flipping a coin? That would just be 50%, right? So to calculate probability, the formula is the number of favorable outcomes or the outcomes you want over the total amount of outcomes. So for the penny example, or for flipping a coin example, the probability of rolling ahead or not rolling ahead, flipping ahead would be 1 over 2 because the coin can be heads or can be heads or tails. So this is one outcome that we want over two possible outcomes. So the probability is 50%, as you guys may know. So let me give you guys a quick question to make sure you understand this. So let's say I have a dice with 6 sides. What's the probability that I roll an even number? So I want you guys to answer this question in the chat.
Yeah. Yeah.
Okay, I'm getting a lot of answers, and the answer is 50% or 0.5. So remember, percent just means divide by 100. So this is the probability, and how we do it is that, okay, let's first see how many total outcomes we can do. So when we roll a six-sided dice, we have 6 options, and there are 3 even numbers between 1 and 6. That's 2, 4, and 6. So the answer is 3 over 6, which is 1 over 2. Okay, that's great. So let's say I'm going to draw out a picture now, and I'm going to ask you guys a few questions, and you can feel free to answer in the chat. Okay, so let's say that this is, these are candies, and let's say that this is my Halloween bag, okay? So this can be like a bag or a jar of Halloween candy, and these are the different candy types. So we have blue candy, pink candy, and red candy. So let me ask you a question here. So let's say I go to the Halloween party and I tell my friend, okay, you can just reach your hand into my bag without looking and grab one piece of candy. So what's the probability that my friend will pick a pink candy? So go ahead and put your answer in the chat. Once you're done with that, go ahead and move on to the second question. So now let's say that I take the candy back from my friend and I put it back in the bag. Okay. So that means the total amount of candies doesn't change. And now I want you to find the probability that a blue candy is not chosen. Okay, so to give a story behind question three, so now let's say that we put all the candy back, and now I tell him to pick two candies. So my friend will take out one candy, and then after taking out the one candy, he'll eat it. No, he won't eat it, sorry. After picking out that one candy, he'll put it back, and then he'll draw another candy. So what's the probability that the first one he got was blue and the second one he got was red? That's question three. And then question four is now my friend will pull out the first candy, eat it, and then pull out a second candy. And we want to find the probability that he pulled out a blue candy, ate it, and then pull out a red candy. Okay, so I'm going to go over question one first. So I think everyone got that right, which is great. So the probability of a pink candy is chosen will just be we have two pink candies, and in total, we have 9 candies. So the first one is 2/9. All right. And with probabilities, you can express them as decimals, percentages, or reduced fractions. All of them are acceptable. There are 10 candies. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, you're right. There are 10 candies. Good catch. So this will be 1/5 or 0.2, 20%. For question two, the probability that a blue candy is not chosen. So that means we'll just count all the candies that are not blue for our numerator. So we have 5 candies that are not blue. So the answer is 1/2. And another way to do this is, so let me put this out here. Another way to do this, which is really important, it's called complementary counting or complementary probability. We'll do 1 minus the probability that we pick blue. Okay. And notice that if I do 1 minus the probability of picking blue, we get the same answer. So I want you guys to notice this complementary strategy, which is very useful sometimes. For question 3, the probability that a blue candy and then a red candy is chosen with replacement is, so the probability that we choose a blue candy is 5/10, and then we multiply this by the probability that we choose a red candy, which is 3/10. And this will give us 15/100, which is 3/20. And then finally, for the last question, the probability of a blue candy and then a red candy is chosen without replacement. So this time we don't put the candy back. Is first we find the probability of choosing a blue candy. So that's 5/10. And then now, since there's no replacement, our numerator went down by 1. So we only have 9 candies left. And then it will be, we still have 3 red candies. So this will be 15/90. Or we can just simplify this like this. So hold on, 3/9 is just 1/3. So we just have 5/30, which is 1/6. Yes, you can simplify fractions before multiplying. It's actually easier to do that. So this is just actually 1/2 times 1/3. Okay, that will conclude our, oh, that will actually, no, we have one more quick thing to go over. So with the probability here, I want you to notice that with these two questions, 3 and 4, we had to multiply probabilities to get the answer. And with question 2, we can do something called the complementary probability here. So complementary probability is really important. So let me just write it out again. So what complementary probability is that, let's say we want to pick the probability of A happening. This is equal to 1 minus the probability of A not happening. So this is very useful. And this also works for just counting how many things are in a set. So if we say we want to find the number of items that are A, this is equal to the total amount of numbers or total amount of items minus the number of items that are not A. So this should make sense. Okay. Now, oh, to answer Zeph's question of why 4 is more common than 3, that's because when we don't replace the candy, it's easier to pick a red one, right? Because there's less non-red ones to pick. So that's why 4 is more common than 3. Okay, now the last thing to go through is just probability represented as an area. So let's say I have a a a darts board. So with darts, we like throw darts on here and they'll land somewhere. And let's say it's a rectangle. So let's say that the right side is the scoring area and the red side is the losing area. Okay. So let's say, and this is not going to be drawn to scale. So some of the figures on the UMTYMP exam will not be drawn to scale. So that means that two sides might look the same, but they're actually not. So you can't just like look at it to see the answer. You have to actually calculate things. So I'm going to purposely not draw this to scale. So I'm going to say this side has a length of 4, and this side has a length of 3, and this side has a length of 1. So let's calculate the probability that you throw a dart randomly and you win. So to do this, let's just imagine we throw a dart randomly, right? Oh, I'm throwing darts randomly on the board. And it seems like we have a 3/4 chance of winning. And that's because probability can be represented as an area. So the probability that we win will just be the area of the blue rectangle divided by the total rectangle. So the area of the blue rectangle is 12, and the area of the total rectangle is 16. And that obviously simplifies to 3/4. And the probability that we lose will be the area of this red rectangle divided by the total area. So that's 4/16, which is 1/4. So that goes over everything that we have for today's lecture. So we can go ahead and do our fun little game now.
All right, we're gonna be playing a Kahoot today. All right. What do you mean? No, you don't like Kahoots? All right, well, we're gonna play it anyways. All right. All right, join up.
I see right now we're having like a Book It versus Kahoot war in the chat. So if you guys really love Book It a lot better, we'll do a Book It next time, okay? But how about this? If you guys beat our TAs in this Kahoot, we'll let you guys choose which game to do next time. How about that? So let's just have our TAs join this game, and if you guys can beat them, if any one of you guys can beat them, you guys will have the choice. The winner will have the choice between Book It or Kahoot, and you can choose the Book It game. So we're gonna put some.
Also, use your real names. Who is this?